All right, so today we're going to learn about exponential functions. So far we've learned throughout the school year linear functions, those are our straight lines, y equals mx plus b. We just finished up with quadratic functions, which were our parabolas. And today we're going to go in and learn about exponential functions. Exponential functions, there's two of them. There's one that's a growth and one that's a decay. And other than the fact that one's a growth and decay, they're the exact same thing. All it means is that something is growing at a really rapid pace or decreasing at a really rapid pace. So just so that way you have an idea of what the graph would look like, this is just a super rough sketch, but growing up rapidly if it's a growth, or going down rapidly if it's a decay. Okay, so again, an exponential function, all it means is that something is either increasing in size or increasing in value if it's a growth, or decay, it's decreasing in size or decreasing in value at a very rapid pace. So like our quadratics and our linear functions, we have formulas for them. So if it's an exponential growth, it's going to look like this. If it's an exponential decay, it's going to look like this. I hope you see that they are the same formula. The only difference is if it is a growth, it's y equals a1 plus r to the x. And if it's a decay, it's y equals a1 minus r to the x power. Okay, so if it's a growth, it has a plus. If it's a decay, it has a minus. Otherwise, it's the same thing. So you can clearly see there are variables in here that we've never used before. So we have to define them. So our a in this problem, or in this formula, stands for our initial value. So whatever you start with, the starting amount, is what's going to get plugged in for a. Then our r, well, the r stands for the rate of growth or decay. Whichever type of problem you're dealing with, the rate is still always the same thing. One thing about your rate, as a hint, it is always going to be a percent. So whatever percent is given to you into the problem, that is what your rate is. And then the last thing is this little exponent. We've never had a variable in the exponent. Well, that's what makes it an exponential function, by the way, is that you have an exponent in as a variable. That's always going to be your period of time. So it could be minutes, hours, days, years, months, whatever they give you in the problem, that's going to be what you put in for your exponent. Okay? Now, before we get into some examples, just one last thing that you have to keep in mind. Whenever we're dealing with using exponential functions, your rate or that percentage must be written as a decimal. You can't just put 23% into a problem. It has to be 23% written as a decimal, 5% written as a decimal, and so on, right? So to change from percent to decimal, all you have to do is move the decimal place over 2 units. So right now with my 23%, I have an imaginary decimal point there. I'm going to move my decimal point over 2 units. So 23% is equivalent to 0.23. So when I'm plugging into my problem, I wouldn't be putting in 23, I would be putting in 0.23. Same idea with my 5. My 5 has a decimal point over here on the end. I still have to move it over 2 units. The only thing is I now have this open space. I fill it in with the 0. So 5% is 0.05. Same idea going forward. Put it on the end. Move it over 2 spots. 17% is 0.17. I have 8%. I put it over 2 units. I have that empty space. I'll fill it in with the 0. 8% is 0.08. And then my last one, I have 4.2. This has the decimal point in it, so I'm going to use that decimal point. I'm going to move it over still 2 units. So 4.2% is 0.042 as a decimal. Okay, so keep that in mind. rate has to be written as a decimal. All you're doing is using the number given and moving the decimal point over 2 units. All right, so let's take a look at an example. Okay, so it says, Marilyn collects old dolls. She purchases a doll for $450. Research shows that this doll's value will increase by a rate of, it doesn't even say rate, I just said that, by 2.5% each year. Write an equation that determines the value, V, of the doll, T, years after the purchase. So we're going to refer back to our exponential growth formula, right? So it's increasing is how I know it's going to be a growth. Growth means it gets bigger. It's increasing. So I'm using my exponential growth. Now, they want us to determine the value in this problem, and we've done problems like this throughout the school year. They give us the variables to use. So instead of using x and y, we have to use the v and the t. So my value, so instead of y, I'm just going to put in v, is equal to my A, again, that's my initial value. Well, what did it start at? She purchased the doll for $450, so that means 450 is my starting. Then we keep going, parentheses, 1 plus my R. Well, what's my rate? My rate is that percent, so I have that 2.5%. Again, I have to move the decimal place over 2 units. Sorry, that is so sloppy, but that becomes 0.025. So I'm plugging in not 2.5, I'm plugging in 0.025. And then after t years, well, remember my x stands for the amount of time. I'm gonna plug in my t. That is my equation that represents the situation. Later on this week, we'll plug in values for v or for t and continue on there. But right now, for today, this is all we're working. We're creating our exponential function. So again, our initial value, our rate, our time period. They told us to use t years. I plugged in t. Let's just look at one more example. This one is a decay. So Daniel's print shop purchased a new printer for $35,000. Each year it depreciates, it loses value. So again, that's how we know it's going to be a decay. So it depreciates at a rate of 5%. Write an equation that determines the value V of the doll, I copied and pasted this, of the printer T years after its purchase. Sorry about that. Okay, so again, we're using our exponential decay problem. It tells us to use the same V and T. So I'm going to start off with the value of the printer is equal to my initial value. Well, it started at this $35,000. So I'm going to put in 35,000 parentheses 1 minus this time, because it is a decay, it is losing value. My rate, again, it's 5%. Starting with my decimal here, I move it over 2 units. 5% is equal to 0.05. So minus 0.05. Again, t years. So I'm plugging in my t for my x. And that is my final answer.